Okay. You quiet now. Thank you. Step 1. I did not get to the notebooks on Friday because Friday was a white day, so that means I'm just all day long. After class today, if you do not need your notebooks or binders or whatever you have your stuff in, if you don't need it for second hour, leave it here. Next hour I have prep. I will go through all the notebooks. Okay? Someone asked about tests. When I put all the notebooks and stuff out on the counter, all of your quiz 1, 2, and 3 for sure, maybe 4, I will just put with your stuff. Okay? Basically, I don't hand the quizzes out, even though it's a different form. I don't hand the quizzes out until after everyone has taken the quiz. Right? Like, even though maybe you were gone for a day, but Anna has a different quiz, I'm not going to give Anna her quiz back until you take yours, even though it's a different form. Okay? So you'll get your quizzes back, you'll have your notebooks, stop by and pick them up after second hour, at the end of lunch, or for Spartan time. You all heard that you're doing stuff for advisory day today.
No, that's today.
Right?
No, that's Wednesday.
Or is that Wednesday?
There were like Easter eggs. Yeah, what the heck? There were like everywhere.
Oh, no, it's Wednesday. All right. Wednesday. But on Wednesday you will do things. Okay. What else?
Yeah, why were there so many? There were like half of the state troopers. There was like 8 or 9 state troopers. So if you want to go skiing on highways, like right now is your prime time.
Someone did something dumb.
Is that what that means?
Are we getting another kid arrested this year?
Probably.
So why would they all walk in so professional?
Probably because that's somebody.
So, we got test stuff, quiz stuff, brownies. Yeah. No daily quiz, no homework, jumping straight in. Where we left off with 2-4, we'll move into 2-5. 1, 2, 3, 4. Assuming nothing else happens, like the sky puking on us, you will have quiz next Tuesday. Okay. Here we go. We did the that. I think we did the that. We did not do the that. We did the that. All right. I dare you. Make the polynomial that has these zeros. Like we talked about last time, they wrote the conjugate for you. You do not need to double up on it. It's just those are the 3 zeros. The thing that gets everyone tripped up is because they wrote it as a single rational expression instead of writing it like this. I recommend write that like that so you know what A and B are. And then use that cheater. And it turns out it's actually not that bad. It looks scary. Get to know them first. Or he gives you open notes on all of your tests and eventually brownies. People tell me that and I don't like it.
You want to be scary?
No, they tell me that I'm intimidating. I'm not.
Oh, so I feel like
Come on now, do the thing. Do the thing. Don't just wait for me to do the thing. Uh-huh.
So it's like an A or whatever.
Uh-huh.
Is like
So they're both over 2. So A is 1/2. B is square root of 11 over 2. Like that.
Okay. Oh.
So A, B.
Okay.
But I'm not going to tell you that because it's going to be even more intimidating.
My sister's not intimidating.
Where's X? Quarters, 12 quarters. 12 quarters is 3.
Mr. Solomon,
Huh?
what if it's a radical and an I? Is it
You don't put I.
You never put the I. It's A plus
yeah,
B,
B.
I. Yep. You use the cheater form for imaginary numbers. It just happens to have a radical in place of B.
I don't know.
It's 11 times negative 1.
11 times. Okay.
Are we going to do 10? Or can I write it in?
We're going to do at least one more. Whether it's 10 or not, I don't know.
10's not that bad. Yeah, but we have no room to write. Hey, on your calculators, low battery.
Yep. They'll last like that for... I haven't charged these since the 3rd week of school. They'll last forever. Womp womp.
I had a bunch. I need a slide. Yes. No, he's just doing. Oh no, he's just multiplying it all out. Oh no. Yeah.
Option 1, the way the book wants you to do it. X minus the 0. Distribute the negative. Go distribution bonkers on it. But as we learned, every time you do, you end up with 2 of these terms. That term cancels. That term cancels. I squared changes the sign. 1/4 plus 11/4 is 12/4, which is 3. Or maybe I don't want to do that, and I instead write this as 1/2 plus or minus square root 11 over 2 I, identifying a as 1/2 and b as square root of 11 over 2. Plug it into my cheater, x squared minus 2a x plus a squared plus b squared. If a is 1/2 and b is square root of 11 over 2, don't include the I. That's taken care of by changing the sign here. I get that. So when I said that cheater is going to get rid of like easily a third or more of your work in the problem, I mean it. Instead of writing all that out, just make sure you got those cheaters on hand. All you had to do was write a is 1/2, b is square root of 11 over 2. Plug them in. Ta-da! Now we still have to get it with our x minus 5, but I'm just saying if you want to avoid all this, get over there. I would do there, there. I would have started my problem like this. Nope. Sometimes we have to learn the ancient magic because it's the only way to do it. Okay? And then distribute. X to the third minus x squared plus 3x. All I do is tack an x onto all of them. A 5 on all of them is a plus 5x squared minus 5x plus 15. Combine like terms. My polynomial is x cubed plus 4x squared minus 2x plus 15. Okay. I tossed the big ugly one here at you. Unlike your quiz, I made sure that the quizzes weren't terrible. Okay. Yes. Which is why we do all of the extra examples in class. So, having known the value of the cheater, let's say, nah fam, not that. No, not even that. Nope. Given these two zeros, create the quartic that they came from. Well, conjugate root theorem says if I have this 3/2 plus square root of 2 over 4, then I must also have 3/2 minus square root of 2 over 4. If I have those two conjugates, then there's going to be a quadratic that made them, so I will use quadratic cheater. Basically, use the cheater twice. Be careful which one you're using as to whether it's a squared plus b squared or a squared minus b squared. Remember, a squared plus b squared is if there's an I involved. A squared minus b squared if there's no I involved. Because you're spacing out when I said it on Thursday?
everyone, wouldn't it be then x plus since it's a negative 6?
Are you going?
I'm just writing it down.
You're doing big oof?
I'm just writing down all my zeros right now.
Oh, yeah.
Would this be x
No, no, no. Oh, okay. It's always x minus the 0. So it's x minus this.
Yes.
X minus.
So when it cancels, what I'm saying is when you
But this
multiply
minus will still give you a minus 3/2.
Yeah, no, I meant the negative 6. I
What?
was talking about No, I meant the negative 6. That's what I was
Oh, no. You never negate that. It's a plus bi, a minus bi. The a stays the same. So it's negative 6 in both of them.
Yeah. So, but when negative 6 multiplies it.
Yes. Okay.
So I separate with the negative.
Why did this one become negative? A is 3/2.
Oh, okay. And then this one should be positive 2.
Mm-hmm.
And
It's just what is A, what is B.
okay.
Don't go changing the signs, just what is A, what is B. Even if it's on the red blinking charge your battery now thing, it'll still last another week. Yeah. Those things are just unstoppable. But, you know, if someone actually sends me a reminder this afternoon, then maybe I'll remember to plug them in. Well, once everyone at the end of 4th hour, I turn my phone's notifications back on. So I'm not going to turn on the charger until I'm walking out of the room, though, because it screams at me.
Just don't open it.
Set up your 2 cheaters. First one is a squared minus b squared. Second one is a squared plus b squared. Because the first one doesn't have i's, second one does. Plug in a and b. A is 3/2. B is squared root of 2 over 4. A is negative 6. B is 2 root of 3 over 3. So, x squared, cross cancel, minus 3x. Here I'm going to have 9/4 minus 2/16. Get common denominators. 36/16 minus 2/16 is 34/16. X squared plus 12x, 36. Okay, you beat me with punch, but yes. Plus 2 squared is 4. Square root of 3 squared is 3. 3 squared is 9. So 4 by 3 is 12, 12 over 9. And then 36 plus 12 over 9, and we'll call it 4/3, is 108 thirds plus 4 is 112 thirds. Whew! No, I just made up numbers.
I actually did it right.
There we go. And nope. Okay. From there, can we do it, just don't want to?
Yeah.
I just care that you can use the cheaters to get the quadratic, okay? Regardless of what the original zeros were. If you can get to the quadratic, I know that you can then distribute. Okay? Okay. So as long as you can get to the quadratic, we're good. That's what I wanted to test. So it doesn't matter what the zeros are. No matter how ugly they are, you can get the quadratic that made them. Maybe make a note to this, because I'll see kids do this sometimes. If I had this equal to 0, and I didn't want to deal with fractions, I could just multiply both sides by 8, right? Get rid of denominator. In fact, this is kind of what I'm preaching to algebra half right now. If you don't like the fractions in the equation, then multiply and get rid of the fractions. Problem is, this is not an equation. An equation has both sides. Multiplying both sides by the 8 is what balances it. You can't just multiply this by 8 because you feel like it. There's no equals. Okay? So don't go multiplying this by 8 and this by 3 just so you don't have to deal with fractions. But if you do multiply them by 8 and by 3 right now, could you do that to work with easier numbers and then at the end of the problem divide it by 24? Because you multiplied by 8 and 3, so then at the end of the problem divide by 8 and 3? I mean, if you don't want to distribute with fractions, right? Multiply this one by 8, that one by 3. Don't distribute with fractions. But then when you get to the end of it, you have to remember all of your terms now need to be... Does that work? That works. It's kind of like if I rinse off the dishes and then put them in the washer, instead of letting it get crusted on there when it's in the washer, and then having to scrape it off when it gets out because it didn't do the job, right? Either you got to do work before or you got to do work after, right?
Depends on how hot your washer is.
I don't know. My washer kind of looks like Chadwick Boseman, so. All right. Yeah. I never did it because it was white day. Remind me what it is at the end of class, because now that's bothering me again. Okay. So, here we go. Write something as a product of linear and irreducible quadratic factors. What does that mean? Okay, but what does it mean in terms of quadratics? If I have an irreducible quadratic. Okay, it's not factorable. So an irreducible quadratic is something that's going to have non-rational zeros. So particularly imaginary. So y'all need to know how to factor. We're going to factor this one for real. Step one, I'm going to rewrite this such that I see quadratic form. X to the fifth minus 18x to the third minus 19x, and then plus 30x squared plus 30. Do you see why I switched just those two in the middle?
Take an X out.
Yep, this is now factoring by grouping. I say these guys got an x in common, leaving x to the fourth minus 18x squared minus 19. This, I'll take a 30 out, leaving a x squared plus 1. This is quadratic form where my middle term is exactly half the degree of my leading term, followed by a constant. So I'll factor this like a quadratic and say x squared minus 19 with x squared plus 1. Okay, I introduced this in Algebra 2. I don't know if our other teachers do. This big polynomial factoring. What are those two expressions? This is factor, factor. What do they have in common? Okay. So if I take an x squared plus 1 out, y'all okay with me tossing that x back in here? Okay. So x to the... Okay. X to the third minus 19x plus 30. Yeah? It's what's left, isn't it?
Yeah, can you take away that? Would it be x squared plus 1 to the third squared?
X squared plus 1 to the squared, what?
X squared plus 1 squared.
No. Just like if I had 15x squared minus 3x, I only take x out, right? I only take x squared plus 1 out.
But there's 2 of them.
Right? I don't take a pair of 3's out. I don't take a pair of x's out. Okay. Now, that was kind of mean of me. I didn't realize that we were going to have to split our 19x on here. And y'all probably don't remember our special form for cubes. Y'all remember a cubed minus b cubed is a minus b, a squared plus ab plus b squared?
Oh, I remember
Okay.
when you write it down.
All right, so we'll just do it lazy way. Feel lucky, synthetic division. Okay, I can't do that as the example when it's something that we need to review, because we'd have to split that and then.
Could we just erase all that?
Don't have to. If I'm going to set it up for synthetic division. Those two? Yeah. Yeah. Please make sure that you have 0 as a placeholder. All right, what do we feel lucky about? Negative 5?
Or 2.
Negative 5, negative 5, 25, 7, negative 35, negative 5, 25, 6, negative 30, skadoosh. Okay. What else? 2. 1, 2, negative 3, negative 6, 1, 2, negative 3, negative 6, skadoosh. What else? You said 3? 1, 3. Okay. What is that last line? How do you know it's quadratic? Okay. I started with a quintic, degree 5. I brought it down by a linear 3 times. So I have reduced its degree 3 times. I should be at a quadratic. This is where they mean a product of linear and irreducible quadratic. I now know that x minus a negative 5, so plus 5, is a linear factor. I know that x minus 2 is a linear factor. I know that x minus 3 is a linear factor. But then I get to the very end of it, and I have this quadratic, x squared plus 1. That's an irreducible quadratic. Because if I set that equal to 0, what happens? I get plus or minus I. I get imaginary roots. So that's why it's called an irreducible quadratic, is I end up with imaginary roots. So rewrite the polynomial as a product of linear and irreducible. So f of x is. They say as a product of linear factors. So all that changes about this is we're going to turn that into 2 linear factors. I still have all these. Oh, if you sing it while there's literally a brownie on the table in front of you, I'm going to flip. Okay. So if I have 2 zeros of I and negative I can write those as linear factors, right? It's always x minus the 0. So turn this into x minus I and x minus a negative I, so plus I. Which should go all the way back to a while ago. I had said if the difference of squares is always x minus the square, x plus the square, then sum of squares is going to be the exact same thing, they just have i's. Square root of x, x. Square root of 1, 1. Just toss an I in there. Okay, so like if I get all the way down to the end here and I see x squared plus 9, I'm just going to know that's x minus 3i, x plus 3i. Because if I had add x squared minus I, it would have been x plus 3x minus 3. Only difference is there's going to be i's there now. Okay? And then list all the zeros. Okay. If I know the linear factors, then I know the zeros. X is now negative 5, 2, 3, plus minus I. And this is where, like, the whole fundamental theorem of algebra, this is like the heart of algebra 2 was I can give you any polynomial, no matter how disgusting it is. You can find all the zeros, you can write the linear factorization of it, you can graph it, you can analyze it, you can do all the stuff with it. I don't see a need in doing both of them if we can avoid it.
I already know which one is going to choose. Don't say God. Don't tell him you're going to choose a harder one.
They're both factorable. A, B.
Wait, that's
Nope. Where is it? Where is it? B. That's if I catch it in the air. So that was legit.
Which one did you want it to
B.
be? That's crazy.
Well, because it's factorable.
How did I know that that's the one you wanted?
Because it's longer and it provides more practice.
He wants us to get the harder ones done.
Would you rather do the harder ones now or encounter them in the homework having not practiced them? Split it two different ways. Yeah, okay.
Are we gonna do A? I'm just wondering what program that is.
Maybe. Okay, I know that most of you went with, all of you, went with the, what do I feel lucky about synthetic division stuff.
I didn't even think about it.
I didn't know we could do that.
Oh, okay. No, I was just going this route to see if my sleep-deprived brain could actually get that part. Okay. So, factoring by grouping, I'm guessing most of us got to yellow. And then, right? The trick is figuring out how do I split these. I know there's an algorithm. I was never taught it. I would never learned it. But now that I'm here, now that I have the magic split, do you see where I can keep factoring? Take out x here, leaving x squared minus 2x plus 1. Take out a negative 12 here, leaving x minus 1. X minus 1, the quantity squared. Okay, if this is x minus 1, the quantity squared, I can take x minus 1 out of both. Leaving x times x times negative 1, minus 12. Which final factor form? X squared plus 9, x minus 1, x minus 4, x plus 3. So more to show you that it can be done. Do you see why we go through all of the steps to do synthetic division? Why we learn Descartes' theorem, why there's a rational root theorem and all that kind of stuff? We teach all of that stuff so that you don't have to just brute force factor something like this. Now, I'm looking at this and I know that 1, 4, and negative 3 are zeros. I know I'm going to feel lucky about those. How many of us would much rather look at the time savings? Say 1, negative 2, negative 2, negative 6, 99, 108. And say 1. All right. Boy, that's faster. Say negative 3. 9 was that negative 27, negative 36. And say, I feel really good about 4. And then at the end, recognize x squared plus 9.
That's so much easier.
Right?
Can we do that?
Yes. Okay.
Yeah, because I just was factoring that, and then my brain broke at like
So,
one of the last steps.
I'm going to say f of x is x minus 1, x plus 3, x minus 4, and then as an irreducible quadratic, x squared plus 9. If I'm going to rewrite that, x minus 1, x plus 3, x minus 4. How do I split that up so I get my linear factors? If this said x squared minus 9, I would just say x minus 3 and x plus 3. Because it's x squared plus 9, that just means I'll have i's. Okay? And then my zeros are 1, negative 3, 4 plus minus 3i. So, yes, you can factor. The factoring takes a long time. Well, sometimes. It depends whether you have to find that magic split in the middle of the factoring problem. Sometimes you already have enough terms to be able to factor by grouping as is. Sometimes you don't. It just happens. Okay? There's an AC method. Well, it's not AC method anymore because it's not A and a C. It's more like a A and a H. But there is a method for splitting that term. I never learned it because I did this instead. Now, let's say you need to find the linear factorization. It says write the factors. Linear factors. But you don't know how to factor it. Are y'all okay with doing this and then reverse engineering? Like do this to find the factors and then write that? You still found the factorization, didn't you? So, wanted to show you both just to prove that one sucks.
On the quiz, would it be like by grouping or like just find it? Or like one of those.
If I ever have one that I say I want you to do it by factoring, you will not have to find the magic split like that.
Okay. Just do it in the way you know that.
That you would be able to factor it as is without splitting anything. Okay. Okay. I got a polynomial, I got a zero. Find all the zeros. Kind of like, well, you know, something stupid happened in the redneck bathroom. I know this kid was in there. Go find the other kids. Well, if that kid was in there, I know this one and this one are probably in there, right? So, if 2 minus 3i happened to be in the redneck bathroom, who else was in there? Then so if 2 minus 3i is a 0, then I know 2 plus 3i is. If I know both of those are zeros, what does Ashlyn think the quadratic is? Called out. Come on now. Plug in your A and B. Get the quadratic. 4 plus 3? 4 plus 9.
Why is it just -3 not -3i?
Because the I is taken care of right there. It's A plus BI. A plus BI. Just like when you first learned the quadratic formula, if I saw this, I wouldn't put negative 4x in place of b. I would just put the negative 4, right? It's taken care of in the formula for us. 4 plus 9 is 13. Hi?
Are those equations on our note thing, like our Holy Grail?
They should be.
I just want to make sure I didn't have to write it.
Well, you should have wrote it down anyway, so.
Well, I did on here,
Yeah.
but I just want to make sure I didn't have to write it.
That's why it's open everything. That way you don't have to hunt. You go where you know it is.
Okay.
So, that would be like me having big honking number like this is divisible by 3. Find the other factors. You would be able to do it, right? If it's divisible by 3, that means I can literally divide it by 3 and I can get what's left. Yes, it is.
It is. I always remember it because
1 plus 5 is 6. 6 plus 3 is 9. 9 plus 9 is 18. 18 plus 15 And since 33 is divisible by 3, the whole number is divisible by 3.
The only thing I remember from like
Okay. So I can find the other zeros in this because I know the quadratic. This is why we had to learn long division, not just synthetic. Because I can now take x squared minus 4x plus 13 and put it into x to the fourth minus 6x to the third plus 20x squared minus 22x minus 13. Nope. That's why we had to learn long division, not just synthetic. Because you're not always dividing by a linear factor. Okay, no. No. Hannah has a valid question here. Why not? No. You can. I'm going to give you an option.
It's gonna be a nasty fraction. Yeah, I'll pass.
Like, that's literally what the book wants you to do. 1 minus 3i like this. Real parts together, negative 5 minus 3i. Now, 2 minus 3i times negative 5 minus 3i. And you FOIL it out like that. And then simplify it. So that's negative 10. So that's negative 10 minus 6i plus 15i plus 9i squared. So that's minus 9, so that's negative 19. So that's plus 9i. So negative 19 plus 9i. Add 20. 1 plus 9i. Do it again.
No.
You can do that all the way, and then with 2 plus 3i, and it will get you the quadratic we're about to get. Do you want to do this, or do you want to do the long division? Okay. Like, that's a valid question, though. Do I have to? No, you don't have to do the long division way. I have found, and every student I've ever talked to says, I would rather do it this way because I know how to do this, and it's faster than that. In fact, if you go and look at the solutions for this section, it will have you doing synthetic by complex numbers. Blech. No thanks. So x to the fourth divided by x squared is x squared times the stuff. X to the fourth minus 4x to the third, 13x squared, change your signs. Getting negative 2x cubed, 7x squared, drop it, little hot. Go again. Negative 2x cubed divided by x squared is negative 2x. Take negative 2x times the stuff. Negative 2x cubed, 8x squared, minus 26x. Change your signs. Getting x squared minus 4x plus 4x minus 13. Is it? I was going to say my signs aren't lining up here. By negative 1. X squared minus 4x minus 13. Change the signs. Whatever, it's going to cancel. And I get here. If I know one of the zeros, I know its conjugate root. If I know the conjugates, I can make the quadratic. If I can make the quadratic, I can divide by the quadratic to find the other quadratic. Tell me what factors of -1 add up to -2? Quadratic formula or complete the square. Whichever way you prefer. It's actually really easy by complete the square. Don't be afraid of it. Variables on one side, constants to the other. Add b over 2 squared to both sides. b is currently -2. Half of that is -1. -1 squared is 1. Add b over 2 squared to both sides. This is now x squared minus 2x plus 1, which can be written as x minus 1, the quantity squared. Like, that's the point of completing the square, is I now have a perfect square. If I have a perfect square, I can solve it by square roots. Add 1. Or quadratic formula. If you don't like complete the square, don't use complete the square. I have to divide in order to get the quadratic. Once I have the quadratic, I can solve the quadratics. You see why, like back in geometry, we spent like 3 chapters on triangles? Because every other polygon can be turned into triangles, right? Since every polygon can be turned into triangles, spend all your time learning triangles. Since every polynomial can be turned into linear and quadratic factors, that's why we've had Algebra 1 and 2, to learn all of the linear and quadratic factors. You ever see that?
Nope. I think I don't know.
There's a lot of stuff that y'all didn't get in geometry. Here, we'll use a fair one. That one. They're the same. If you know one of the factors, create the quadratic that the factors came from. Use a cheater. Once you got the quadratic, long division, unless you want a synthetic.
If you're a hardhead, why can't you just like forget that 0 and just do the problem as you would just find?
Because it's not going to have any rational zeros.
Oh.
Look at the last one that we just did.
So
the last one had 2 irrational zeros and 2 imaginary zeros. You can't find them by synthetic division the way we did the others, because all of the zeros are ugly. That's because you spent that whole time on your phone. We're into some pretty heavy alphabet soup here. It's not that it's difficult, it's that it's long, it's tedious, there's so many moving parts. This is the difference between grandma got you a $10 Lego set for Christmas versus your nerdy uncle got you the $200 Death Star.
What if you got you the $600 discontinued one?
That one's really cool.
There's two different versions of the Lego Death Star. One of them is discontinued, so it's like worth a lot of money, especially if it's like still in the box and not built at all.
It's also about like yay big, and it actually has the partial tiers from Return of the Jedi instead of the full sphere. It's really cool. Yeah.
Like the big Millennium Falcon.
That's cool.
I got the Lego.
I don't have that one.
I drive 5.5 hours to go to Riverside. I just drive to get out of the house. I actually have
It's not acceptable. It's not acceptable. I'm sorry.
Step 1. Identify A and B. Make your quadratic. Before you go dividing, make sure that your quadratic is correct.
Yep.
I did a squared minus b squared because there's no I involved. Once I know the quadratic that goes into this, I can divide by that quadratic. X to the fourth divided by the stuff. Multiply. Change your signs. Negative 6x cubed divided by x squared. Distribute. Change your signs. $10x squared minus 40x plus 10. 10x squared divided by x squared is just 10. 10 times the stuff. 10x squared minus 40x plus 10. Change your signs. And if you're like me, you get to the end of this and you breathe a sigh of relief when you hit that 0. Like, okay, cool, I did it right. Because it should go in there evenly. But you ain't done. You still have to solve that quadratic. This is to find the other quadratic. The other quadratic we have now found is x squared minus 6x plus 10 equals 0. You do it however you're going to do it. I'm going to complete the square. Okay. I am partial to the completing the square because honestly, there's more moving parts to quadratic formula. Like, there's only about 3 mental math steps to doing complete the square. So that's always been more of my jam.
I always forget the equation for it, even though it's super easy. I just always forget how to find the first.
Divide everything by a. Variables here, constants there. Add b over 2 squared to both sides.
I always forget to do b over 2 squared though. That's what I always forget.
Get a tattoo?
I already have a tattoo.
Plus b over 2 squared, right there.
Try it.
Oh, on my shoulder blades. Took about 4 hours. It's my first tattoo. It's like that big across my
So it's
back.
like all over your back.
My wife got the full calf done this summer.
Yeah, this is my first tattoo.
That's a bunch of like sea turtles and stuff and bubbles, and it's full color. It took like 8-9 hours. Yeah. So, did everyone get to the end of the rainbow? Find the other two? This is like, if here's a polynomial, solve is the meat and potatoes of algebra 2. This is like the chewy 3-day-old pot roast. You got to be able to eat it. Okay? You got to be able to eat it if you have to. This is great grandma's lutefisk. Okay? Right? You chew it and it bounces back. You try to swallow part of it and the rest of it follows. Lutefisk is so gross. Okay. Okay. Honesty thumbs. I don't care if you like it. Can you? Make the quadratic, divide, get the other quadratic, solve. Okay. Then. No. We have already missed 2 different days, so no. Rational functions can be written like that. We've already run across them a few times in here because they assumed that you remembered it from Algebra 2. Our Algebra 2 does not cover them because you cover them in Algebra 1. And that is something we are remedying this year. You did this back in Algebra 1.
That was 4 years ago.
Not to this level. No. No. So, but we have been seeing them. We have been seeing them in all of our, remember our continuity tests? The butt crack graphs, right? Those. Okay, we have been seeing, now, over a quadratic. That's not something we saw in Algebra 1. This is why, Mariah, this is why we are changing that. So we are taking the rational functions from Algebra 1 and we are bringing them up to Algebra 2 with the full, not Monty, the full, we're doing these. There we go, words. Okay? So, a rational function is anything that can be written as numerator over denominator. What the numerator and denominator are really changes the graph. The basic graph that we're used to is this. That's what you saw in Algebra 1. That has the parent graph 1 over x. where I would take those crosshairs, those vertical and horizontal asymptotes, and I would move them like this. Okay. So this is supposed to be in Algebra 2. Our Algebra 2 doesn't cover it because you do this stuff in Algebra 1, and then we do the whole shebang here in a PreCalc. So we're changing that so that we have all of rational functions in Algebra 2 this year, because A, it really hurts freshman brains. B, we have so many kids who come into PreCalc having never seen this, and then we do all of our continuity tests and limits and all that kind of stuff with them, and you go, dude, what? Because it's been forever since you've seen them. Also, we want them in Algebra 2 for kids who are about to go take an ACT. Okay? So, you're going to have vertical and horizontal asymptotes. Vertical asymptote, gap in the domain. Because every vertical line is x equals number. They're saying x can never equal this number. Like, what was the second Hunger Games? You know, she falls down the hill, the big rolling fog bank of death is going to melt her face off. It's coming down the hill, and it's, she's going to get it. It hits that wall, that invisible wall. Okay? So anyway, yeah, the old lady saves other people because she's old and going to die, right? So, that vertical asymptote, I want y'all to hear this part. Vertical asymptotes can't be crossed. You can never go through them. It is the invisible force field wall. Okay, it can't be crossed until Calc 2. So if vertical asymptotes are x equals number, horizontal asymptotes are y equals number. They're a gap in the range. Unfortunately, we are going to find that you can sometimes cross through horizontal asymptotes or even oblique asymptotes. You can cross through these under very specific circumstances. And it's when there's an intersection between this function and that line, like as a system of equations. It's like T'Challa saying, you know, open sector G28. Okay? It's this one little boop, hole in the force field to let them through. Okay?
Is that connected at the bottom?
Yes. That is a weird looking graph.
Don't look at me.
You know what you did. Okay? So,
Well, it's because you called the other one that made me call that. I looked at the other one.
find the domain. Find the vertical and horizontal asymptotes. So, I know where this graph is. I know where its vertical and horizontal asymptotes are because, well, I teach this stuff. If you don't know where those vertical and horizontal asymptotes are, let's come over here and start analyzing the graph. Alpha y equals. We have, what is it, x plus 4 over x minus 3? Right? Yeah. Okay. I do that, I'll zoom back to standard. And I get this graph. So, based on this graph and that function, what would you say is the domain of this thing? That we should know because we did this back in chapter 1. Not 3, right? Does it say find the domain or does it say find the restrictions to the domain? Okay, what's the difference in my answer?
Crossing out 3 and negative.
Okay, if I say state the restrictions, I'll just say x doesn't equal 3. If I say state the domain, then I have to actually write negative infinity to 3, can't touch it, and 3 to infinity. It's whatever makes the denominator 0, right? Set the denominator equal to 0. Okay, out of curiosity, range. I know it doesn't ask for it, but take a look at your graph and tell me, what do you think the horizontal asymptote is at? You think it's at 1, okay? So I'm going to make my window a lot bigger. I'm going to say my x's will go negative 30 to 30. Now, if that's true, I'm going to go to y2. I'm going to put in 1. Still going with 1. Now, I could make this go out as far as I want to. Unfortunately, the ask feature for y's doesn't actually work. Okay. Now, if it ever equals 1, I should be able to find an intersection between them. And it says, no, that's still yellow circle.
Mine broke.
If it goes, oh, there you go. Error, no sign change, meaning there is no intersection between them. How about this? If we think that y isn't allowed, plug 1 in for y. And just try it. Cross multiply and you get x plus 4 equals x minus 3. Subtract x from both sides. 4 does not equal 3. So that's how I know that y is indeed never 1. Because when I try y as 1, it breaks math. So my range is going to be negative infinity to 1. Can't touch it. And 1 to infinity. So I have my domain and range. I didn't state my asymptotes, though. If the domain excludes 3, that means I have a vertical asymptote at x equals 3. If my range excludes 1, I'll say I have a horizontal asymptote at y equals 1. Okay? Try that a little faster. Oof. Get a little bigger. Y is quit. Y is clear. Clear. And I'll say alpha y equals thing 8x squared plus 5 over 4x squared plus 1. I'll zoom back to standard. And we get pressed ham. Okay? Pressed ham is synonymous with pressing your butt cheeks up against a window. You would know this if you got kicked off of the school bus for mooning Shannon Sand when you were in 6th grade. So, she ratted me out. Okay? Now, do I actually have a gap in the domain? But it was funny. Okay. Do I have a gap in the domain? I don't see. Okay, now this metaphor is kind of biting me here. I don't see a gap here at all. How do we get a gap in the domain anyway? X can't equal this number, right? Commandments of domain, do you remember what they are? I can't take number divided by 0. I can't take even root of non-positive. I can't take log of non-positive. Okay. So the thing in here that's going to make this equal 0 is my denominator, or is going to break math will be my denominator. Set your denominator equal to 0 and solve. And when I try to solve, I get imaginary answers. So I'm trying to find what numbers will break math. And I ended up with imaginary numbers. What does that mean? Nothing will break math, all real numbers. Okay? So my domain is all real numbers, which means my vertical asymptotes do not exist. There is no vertical asymptote because all real numbers are allowed. It does ask for horizontal asymptotes, though. So where do we think that particular pane of glass is?
1,
1.
I think it's 2. It looks like it's pressed up on 2. Okay? We definitely know it's not 1, right? So try 2 and see what happens. Cross multiply. 8x squared plus 5 is 8x squared plus 2. 5 does not equal 2. Okay, so 2 isn't allowed. So that means my range, in this case, is going to be from 2 to infinity, and my horizontal asymptote is going to be at y equals 2. Okay, now there's a trick to finding the horizontal and oblique asymptotes. But for now, let's just say, can we find them knowing what we already know? Yes, ma'am. No.
because it stopped at 5.
Oh, yeah, it did. So we would have to say 2 to 5. Sorry, I'm used to the actual butt crack where it goes up to infinity, because that's what. Good call, 2 to 5.
So would that change our...
No, you're right. And I owed you one from before.
I didn't think that you should be having one for the K of X and then one for what 2 is. No, the K of X one does not count.
K of X is just mean. No. All right. I do want you to do both because they both have a certain flavor to them.
What?
On part A, you will need to make your window a little bit bigger. I would say move your y's out to at least plus or minus 20.
Oh, I definitely
But you saw it, though.
Then I don't know what
Okay. Maybe a little bit of guess and check. Maybe try that horizontal line feature in your calculator. How are you going to get that horizontal asymptote? I said I wanted you to do both because of those different flavors.
It's not 11.
Now our vertical asymptotes, those are just denominators. I say we're doing okay with those. I know that we're okay with our vertical. Horizontal, did anyone find it for part A? It is 15. Yep. And in this one, we have an oblique asymptote, so there's no horizontal. If you do not need your notebook for next hour, please leave it on my desk. I will get to them during block 2. Hi. What did I want?
23 or something like that.
23 from 2-4. Okay. Okay.
Oh, where do I put this?
Pile.
Oh.